Hi guys, I'm going to talk to you about graphing polynomial functions. I used to have kids do this by hand, and it's a really good exercise and kids are good at it. I don't think we'll have time to do that this year, and your math lab is going to be multiple choice guessing, so it'll be multiple choice. So you'll think it's very easy. I do want you to understand how we would graph this by hand because I think it really helps you understand polynomials better. Okay, so the first thing you need to know is what this means by turning points. If a polynomial function has degree n, so if the degree is 4, then we know there are 4 zeros, and that means that there is at most 4 x-intercepts, because we talked about there could be double roots, or there could be triple, multiplicity 3, all these things could happen, but there could be 4. And then at most, 4 minus 1, which would be 3 turning points. So where does the turning point happen? Like on our cubic graphs, remember how sometimes I said there's wiggles? So this is a turning point and this is a turning point. The degree is 3, and there was a turning point here and a turning point there. Now, that does not have to look that way. The mother function for x to the third is like this, and there's no turning points. Doesn't have to be that many, but there could be, okay? And that happens at the max or mins, and that's kind of what you're looking for. The turning points to me is not so important. This first one is essential, though. You really need to know how many zeros you're looking for and how many x-intercepts you're looking for. And the turning points isn't as important as long as you know what your graph looks like from outer space, that you can see the whole piece. Okay, so let's go ahead and talk about the steps to graphing. So when you graph a polynomial function by hand, here's what you do. You use the leading term test to determine the end behavior. What I tell kids to do first is, that was very fancy talk, look at degree and do a ballpark sketch. It's not going to be good, but if the degree is 3, on the side of my paper, I'm going to write this. If the degree is 4 and it's a negative, I'm going to draw this. Why do I do that? So I remember what my graph is supposed to look like. Okay, so then what do we do next? Well, the next thing we do, I didn't want to erase that. Find the zeros by solving any real zeros. Okay, so then remember, we're doing this without a calculator. Okay, so step 2 would be to find the x-intercepts. And we do that by factoring or solving. And you know how many you're looking for because of the degree. You know how many by the degree. And then what you do is you graph those. And you should graph your y-intercept as well, which you will also know. And then what you do is oh, sadness. Oh, y-intercept is all the way down at 4. I put it up there with number 2. Y-intercept is easy because it comes right from your constant. Graph x and y-intercepts. X-intercepts you just found, y-intercepts are from your constant. Okay. Now the next thing you do is you pick points in between the zeros. You plug into equation like an XYT table to get an in-betweener points. And the reason you want to do that is because that will give you a hint as to how far up or down the graph goes. Okay, so those are the first 3 steps. And then basically, if you need more points, find them. and try to connect points based on Sketch. And then what would you do afterwards? I would just check with the calculator, see how you did. Step 6, I would just check with the calculator. Okay, things to consider. Remember what the multiplicity looks like, what odd and even multiplicity looks like. Odd multiplicity goes through, even is the bounce. Okay, so don't forget that. Okay, so let's see if there's an example. I'm sure there is. All right, we're going to graph it by hand. Okay, this will be exciting. So first thing it said to do was look at it and say, okay, it's 4 degree is even. This is step 1, just a little sketcharoo. It'll be a negative U-shaped graph of some sort. Okay, the degree is 4, so I'm looking for 4 zeros. So now I'm going to solve, hopefully by factoring. So let's see if I can factor that. And I can. There's a GCF. They have, I'm going to go ahead and pull out the negative x to the third. I'm going to pull out a negative x to the third. That leaves me with a 2x and a plus 3. Double check because we just divided out. Negative 2x to the fourth. That'll be a minus 3x. I did that wrong, didn't I? Because I pulled out the that negative, which will make this a minus 3. If you wanted to just pull out a positive, that would have been fine. If you would have just pulled out an x to the third, then you would have had negative 2x plus 3. That would have been fine as well. You'll get the same answer either way. So I factored it, and now I can find my zeros. So what are my zeros? Well, my zeros are this first guy or this guy has to equal 0, remember? So my first 0 is 0, but that is multiplicity 3. And my next guy would have to solve 2x minus 3 equals 0. Add 3, divide by 2. And I get 1.5 as multiplicity 1. So we are going to graph that and our y-intercepts. Okay, so what I got here? I got 0, and I got 1.5. Y-intercept is 0, so it's already graphed. I know the graph is going to be a Frowner face. So now it says to pick points in between to figure out what's going to happen. Well, this graph is going to go down, obviously. But how fast is it going to go down? So when I make my XYT table, I'm going to pick some points in each region. So pick a point over here. How about -1? I'm going to plug that point in. I'm definitely going to pick 1 to see what happens there. And then why don't we just do 2? So I'm going to plug these 3 points into my equation to see what I get. So -2 times -1 to the fourth, well, that'll just be +1, plus 3 times -1 to the third. I'm getting -5. So -1, -5. So it goes down pretty fast. It's going to go down like this. Let's see what happens at 1. Like how high up does it go? Does it go way high up or does it just barely go up? Let's plug in 1 and see. That'll be -2 plus 3, which is just 1. So 1, 1 is about how high it goes. Now, I don't know that that's the maximum, but it's not going to go much higher than that. And then what happens here? If you're, well, I already messed up because I erased what I had. The 0 was a, this right here, if you remember, was multiplicity 3. So it should have hesitated a little bit when it passed through. So it should have been like, hesitate, then go through, and then back down, and something like that. I don't know. But 1, 1 is definitely on there. But do you see how I hesitated? I changed that to make it a little squirmier. And then when I plugged in 1, I got 1. Plug in 2 and see how fast it goes down. Negative 2 times 2 to the 4th plus 3 times 2 to the 3rd. That's negative 8, and that goes down pretty fast. And that's a single root. That's 5, 6, 7, 8. So it'll be down here. And whoop, there it goes. That's what I think my graph looks like. And then you type in your graphing calculator to see how you did. Y equals negative 2, x to the 4th. What was it? Plus 3, x to the 3rd, I think. How's it look? Oh, not too bad. That's pretty much what mine looked like. I almost forgot the hesitation, which would have been fine. But that multiplicity really kind of lets me know that it's supposed to hesitate and then go through. Yeah, I'm pretty happy with that. Okay, so let's look at another example. They do it much more dramatically than I do. Oh, I guess that's it. We just did the one example. So awesome. Now, the intermediate value theorem, what it does is this. They're saying, and you will have to use this on your test and everyone will forget. They want the intermediate value theorem tells you if a 0 is between two numbers. Okay? It's all about the sign. And here's what it does. You plug in each number. So they're saying that the numbers are going to be A and B. So you plug it in. You're going to plug in P of A and P of B. So what you think about what this is meaning, if you have an XYT table, and I plugged in A here, and I get a number, and I plug in B here, and I get another number. What this says is, if the signs are the opposite, meaning one of these is plus and one of these is minus, there is definitely a 0 between the numbers. And we use this all the time. If you can't quite find the 0, looking on your table, and you're like, oh, but look, it went from plus to minus. Let me start my table at A and make my steps smaller so I can maybe find where the 0 happens. Because if it goes from a positive number to a negative number, 0 has to be in between there. So the signs are opposite. There is definitely a 0 between A and B. Now, if the signs are the same, if signs are the same, we don't know. There's not enough info. And I want you to think about that. If this was 5 and then this was 12, yeah, you might say, no, there's not a 0 there. Maybe there is. Maybe A was negative. Maybe A was over here and B was over here. And yeah, this is at 5 and this is at 12, but maybe somewhere in between it went down and back up again. Or maybe it bounced. You don't know what happened in between those 2 points. Now, if one was negative and one was positive, there has to be one that goes between it. But if they're on the same side, we just don't know. There's just not enough info. Okay, so they will look like this. They'll give you an equation. They'll tell you, is there a 0 between negative 4 and negative 2? So all you need to do is do f of negative 4 and f of negative 2, and we're going to see what happens. Well, f of negative 4, use your parentheses. Make sure you don't mess that up. Negative 4 to the 3rd plus negative 4 squared minus 6 times negative 4. That's negative 24. Plug in the negative 2. Negative 2 to the 3rd. Oh, sadness. Negative 2 to the 3rd. Negative 2 squared minus 6 times negative 2. And I get 8. So one's negative, one's positive. Is there a zero between there? Yeah, there has to be. Does it have a real zero between there? Yes. On this next one, if you plug in -1, you get -1 plus 1 plus 6. That's going to be 6. That's positive. Plug in 3. I'll do that one with my calculator. 3 to the third plus 3 squared minus 6 times 3. And I get 18, and that's positive. So they're both positive. So is there a zero? Don't know. Maybe. Don't say no. You say, I don't know, or not enough info, or maybe. What did they say back here? I should have. It says it just cannot be used. That's what it says. Cannot be used. Okay. And then they give you an example of what I just talked about, and they were looking at the graph that time instead of just plugging things in. And that's it. So the notes are fast today. A lot of time to look over the homework problems from yesterday.